There is a number that scientists use when they want to describe the universe, and the moment you genuinely try to absorb it, something in your mind quietly gives up. Not because you aren't intelligent enough, but because the human brain was never built to hold distances like this. It evolved to navigate a savanna, to estimate whether a predator was 20 meters away or 200. It was not designed for what we are about to walk through, a sequence of scales so enormous that each step makes the previous one feel like nothing. We begin at home. The Earth is roughly 12,700 kilometers across. That sounds substantial until you consider that light, the fastest thing in the known universe, crosses that entire distance in less than 1/20th of a second. The Moon sits 384,000 kilometers away, a distance light covers in just over a second. These are numbers that feel manageable. They aren't. At the speed of a commercial aircraft, reaching the Moon would consume nearly 20 years of continuous flight. The Sun is 150 million kilometers from Earth. 8 light minutes. A photon of light leaving the Sun takes around 8 minutes and 20 seconds to reach Earth. This is the distance that sustained every living thing that has ever existed on this planet. The warmth of that 8-minute gap is the reason you are here. Now abandon the solar system entirely. The nearest star to our Sun is Proxima Centauri, approximately 4.2 light-years away. Light years, not light minutes, not light hours, years. At the speed of the fastest spacecraft humanity has ever launched, reaching Proxima Centauri would require over 70,000 years. Not generations. 70,000 years. Agriculture is only 12,000 years old. Written language is younger than that. And Proxima Centauri is our neighbor, our immediate cosmically adjacent neighbor. The Milky Way, the galaxy containing our Sun, Proxima Centauri, and roughly 400 billion other stars, spans approximately 100,000 light-years from edge to edge. If you compressed the entire distance from Earth to Proxima Centauri into a single centimeter, the Milky Way would still stretch 24 kilometers across. This is our galaxy. One galaxy, the structure we inhabit. Beyond our galaxy, the scale shifts again. And this is where the human mind begins losing its footing. The Andromeda Galaxy, our nearest large galactic neighbor, sits 2.5 million light-years away. The light currently arriving in your eyes from Andromeda departed before Homo sapiens existed, before any modern human walked the Earth. You are not seeing Andromeda as it is. You are seeing it as it was when our ancestors were still evolving. The Milky Way and Andromeda are both members of a gravitationally connected group called the Local Group. Roughly 80 galaxies spanning about 10 million light-years. Beyond that lies the Virgo Supercluster, a structure containing hundreds of galaxy groups sprawling across 110 million light-years. And even this, which already exceeds comprehension, is a minor appendage of something larger. The Laniakea Supercluster, the enormous cosmic structure that contains our Virgo Supercluster, our Local Group, our Milky Way, our Sun, our Earth, and every human being who has ever lived, stretches 520 million light-years across and contains the mass of approximately 100 quadrillion suns. 500 million light-years. And it is not the largest thing we have found. In early 2025, astronomers announced the discovery of Quipu, a superstructure in which galaxies group together in clusters and clusters of clusters. Quipu spans roughly 1.3 billion light-years across and contains a mind-boggling 200 quadrillion solar masses. It stretches some 1.3 billion light-years long, more than 13,000 times the length of the Milky Way. It is named after an ancient Andean knotted textile, because like that textile, it is a complex system of one long filament with multiple branching threads. It is the most massive known structure in the universe, containing 200,000 times the mass of the Milky Way. Quipu exists in what astronomers call the nearby universe. There are structures further out, that make even Quipu look modest. Scientists reanalyzed data from 542 gamma-ray bursts and found that the Hercules-Corona Borealis Great Wall may span an astonishing 15 billion light-years, 50% larger than previously thought. To cross it at the speed of light would require 15 billion years, longer than the current age of the universe itself. According to current models, nothing in the cosmos should exceed about 1.2 billion light-years in size. Yet this superstructure is more than 12 times that limit. It is a structure so enormous that its very existence challenges our fundamental understanding of how the universe is supposed to be organized. In May 2026, the James Webb Space Telescope delivered something that stopped astronomers mid-sentence. Researchers produced the most detailed map of the cosmic web ever made, tracing the network of galaxies all the way back to when the universe was 1 billion years old. The map traced nearly 800,000 galaxies, and structures that previously appeared as single objects in Hubble data now resolve into multiple distinct components in the JWST map. Scientists who had spent entire careers working with Hubble watched the comparison and fell silent. The cosmic web is the term scientists use to describe a skeleton-like framework of filaments and sheets of dark matter and gas along which galaxies gathered and evolved over time, punctuated by nearly empty voids. A singular, intricate, far-reaching structure that traps galaxies and galactic clusters like flies strung along the sticky silk of a spider's web. And JWST is now mapping it in unprecedented detail, revealing that the architecture of the universe at its largest scales is even more complex, more structured and more staggering than any model predicted. Now, the observable universe. Everything described so far: Earth, the solar system, Proxima Centauri, the Milky Way, Laniakea, Quipu, the Hercules-Corona Borealis Great Wall, the cosmic web itself. All of it exists within what astronomers call the observable universe, the region of space from which light has had enough time, since the Big Bang, to actually reach us. The observable universe is a sphere with a diameter of about 92 billion light-years and a volume of about 410 nonillion cubic light-years. The word nonillion contains so many zeros that writing it out would require more digits than this sentence has characters. But here is what makes the mind genuinely fracture. The observable universe is not the universe. It is merely the portion we can see from our position in space, bounded by the distance light could have traveled in 13.8 billion years. Beyond that boundary, space continues. One idea is that if the cosmos expanded at the speed of light during its earliest inflation phase, then it should be 100 sextillion times bigger than the observable universe. Other researchers concluded that the universe is at least 250 times larger than the observable universe, roughly 7 trillion light-years across. But ultimately, science has no reliable estimate of the actual size of the entire universe. It may be infinite, genuinely mathematically, physically infinite, extending in every direction without boundary or edge, containing an uncountable number of galaxies, stars, and worlds forever. Pause and sit with that for a moment. Everything you have ever known, everyone who has ever lived, every war ever fought, every civilization that rose and collapsed, all of it occurred on a single pale rock, orbiting an unremarkable star in one ordinary galaxy among at minimum 2 trillion galaxies in the observable universe alone. And the observable universe may itself be a vanishingly small fraction of what actually exists. There is no framework your mind can build to contain this, no metaphor adequate enough. The universe does not scale down into something graspable. It resists comprehension completely and permanently. And yet, here you are, a creature assembled from ancient stardust, on a rock in the middle of an infinite ocean, capable of measuring the distance to the edge of the observable universe, capable of discovering Quipu, capable of mapping the cosmic web, capable of asking how large the universe is and understanding, at least partially, why the answer is terrifying. The universe is not trying to make you feel small. It simply is.